Hi, I'm Alan Ake from Guerilla RF. I'm Vice President of Applications Engineering. My team and I have got a few decades of experience supporting MMIC devices for a broad range of RF applications, from VHF frequencies up to X-band and beyond. Over the years, we've developed a fairly detailed perspective on how you go about selecting the ideal device for a particular application. Today I'll focus primarily on amplifiers, since those are the majority of the slots in an architecture that you'd be picking parts for. First thing, from your system standpoint, you determine what the requirements are for your application, and that'll be the required gain, noise figure in the case of LNAs, and linearity, primarily if a device is in your transmit lineup. You've got a myriad of devices out there, and what you want to do is be able to look at the data sheets from the various manufacturers to find out if this part is going to be ideal for your application. You look at gain, noise figure, IP3, compression point, that kind of thing. And typically you'll go to the second or third page in the data sheet and there'll be a spec table. Well, that spec table is typically written around 25 degrees C. There'll be very specific measurement frequencies for all the numbers that you see there, okay? So, beyond that spec table, what you have to start asking yourself is, what does this performance look like over frequency, right? I mean, you might have an application that's out of the range of the spec table. The spec table might be taken at 2.5 gigahertz, but your application might be at 2 gigahertz. So somewhere in that data sheet, you'll typically see a broadband plot of S parameters that'll show the performance over multiple gigahertz of frequency. So you can get an idea of what it's going to look like in your band. Also, the gain will change over temperature, so you're going to want to look at things like gain and noise figure over temperature, because your system will typically not run at a very tight range of temperature. So you're going to want to look at minus 40 to 85, or in some cases 105 degrees C. Linearity is another big issue to look at over temperature as well, and you need to look beyond the spec table, because spec table for a parameter like IP3 might show a very good number, maybe 46, 47 dBm for IP3. That's going to be at one specific measurement point with a very specific tone power level, tone spacing, and at 25C, like everything else in the spec table. You need to dig further into the data sheet for IP3 performance over tone spacing and over temperature, because you can find a lot of difference between one part and another in how they vary over temperature and that tone spacing I mentioned. Getting into IP3 in a little bit more detail, it's kind of a difficult measurement because it's very sensitive to the tone spacing I mentioned, and also to variations in things like temperature. And one way to look at the linearity of your device that I think is more representative for your system performance is to look at things like ACLR and EVM performance over temperature. By seeing those curves, ACLR versus P out and EVM versus P out over temperature, it really defines how the device is going to be working in your system in a real world condition. Beyond linear drivers and power amplifiers, that kind of analysis is also very helpful even with low noise amplifiers, because as a LNA designer, you really need to understand what is the EVM contribution of the LNA to your system over the full range of input powers that LNA might see. So at Guerilla RF, we are adding that EVM and ACLR performance data over temperature and power level to all of our data sheets, because we feel like it's a critical thing that you need to look at. One other thing is stability for the devices. Typically, devices are advertised to be unconditionally stable, but you do need to take a good hard look at how that performance behaves over temperature. It's something where a device could be unconditionally stable at 25 degrees C, but at minus 40 C, it could easily have potential issues with stability. So that's really about it. It's just a little glimpse into some of the finer details of what you need to look at when you're selecting a device for a particular application. And thank you very much.